Hi everyone, myself Nithin Heraje, Assistant Professor, Department of Computer Science and Engineering, AJ Institute of Engineering and Technology, Mangaluru.
In this video, I'm going to discuss about wired LANs Ethernet from Module 5, so which covers Internet Protocol and Standard Ethernet, Fast Ethernet, Gigabit Ethernet, and 10 Gigabit Ethernet. So the Ethernet protocol, the TCP/IP protocol suite does not define any protocol for a data link of the physical layer. TCP/IP accepts any protocol at these two layers that can provide service to the network layer, that is the protocols of data link and physical layer. IEEE has subdivided data link layer into two sublayers, so that is logical link control and media access control. So the data link control handles framing, flow control, and error control. You can just look at this diagram, how the data link layer is divided into uh, logical link control, and this is about the media access control, and this is about the physical layer. Okay, so this is under OSI or TCP/IP, and this is how it looks in the IEEE standard. So the this shows the Ethernet evolution. So we have the standard Ethernet with the 10 Mbps speed, fast Ethernet 100 Mbps, then gigabit Ethernet which is 1 Gbps, and the last is that 10 gigabit Ethernet which is 10 Gbps. This is the Ethernet frame format. You can just have a look at it. So here there is a preamble with 56 bits of alternative ones and zeros. So this preamble is of 7 bytes, which tells you the start of the frame, and which has ones and zeros, alternative ones and zeros for all the 7 bytes, which is 56 bits. And there is a start frame delimiter, which is of 1 byte, and which is a kind of flag, delimiter flag. So this is the bit pattern of the flag, and so this contains of total of 8 bytes, which is an physical layer header. Okay, so this is the physical layer header over here. And if you look at this, there is a destination address which is of 6 bytes. Next is the source address, which is of 6 bytes again. And this is the type, which is 2 bytes. The type defines the upper layer protocol whose packet is encapsulated in the frame. Okay, so it might be either IP or ARP and so on. Next we have is data. So data and padding, because if say you have maximum payload of length 1500 bytes, and in case you are having only 1000 bytes of data, the rest of the 500 bytes need to be padded. So that's why there is data and padding. So this field, it should have a minimum payload of length of 46 bytes, and maximum is 1500 bytes. Okay, and this is the CRC, cyclic redundancy check, with 4 bytes to detect in case there is any error. All right, so totally thus frame which is from the data link layer will have 64 bytes. Okay. So the frame length, the minimum frame length is 64 bytes, so it should have minimum 64 bytes, and maximum is 1518 bytes. Now, if you look at this, this is an Ethernet address in the hexadecimal notation, which uses 6 bytes over here. Okay, each byte separated by a semicolon, and this has 12 hexa digits. Okay, totally of 48 bits. Now, if this is the address, so how is it sent? Okay, the address is sent left to right, byte by byte. So first this byte will be sent, next this byte will be sent, and next this byte will be sent. That is from left to right. Okay, so this 47 in binary, it is like this. Okay, 0 1 0 0 0 1 1 and so on over here. And for each byte, it is sent right to left, bit by bit. So this is in terms of bit. So bit has to be sent from right to left, that is from this point to this. Okay, if you look at this, see, this one bit is here transmitted, this one bit is here, this one bit is here, this 0 bit is here. Okay, and so on. So the byte is from left to right, that is 4721 byte to E08EE. And after converting it to binary in terms of bits, it should be sent from right to left. That is this particular 47, it has to be sent from right to left. So 1 1 1 0 0 0 1 0. So this is what you transfer. So it applies to all. Okay. Next is unicast and multicast address. So unicast means, as you all know, it is one to one. Broadcast is one to all, and multicast is one to many. Okay, just look at this. If the least significant bit of the first byte, so this is the first byte, and this would be the least significant bit. Inner destination address is 0. So in the destination address, it should be. Okay, if it is 0, the address is unicast. Otherwise, it is multicast. So if this bit is 0, it means that it is a unicast, and if this particular bit is 1, then it is multicast. Then what about the broadcast? So all these bits, if all these bits are 1, then it is a broadcast. So the least significant bit of the first byte defines the type of address. If the bit is 0, the address is unicast, otherwise it is multicast. So the broadcast destination address is a special case of the multicast address in which all bits are 1. So if it is a broadcast, then all the bits should be 1. So we'll define the type of following destination address. So we know it all depends on the first byte. So based on 4A, FF, and 47. Okay. So if you look at this in the least significant bit, A means it's a even number. Even number in the sense the least significant bit should be 0. If you look at this 7, it is an odd number. That means the least significant bit should be 1. So you will know if this is 0, the least significant, then it is a unicast. So A is unicast. If the least significant bit is 1, it is multicast. Since this is 7, which is an odd number, so least significant bit becomes 1. And this would be the multicast address. And this look at this, it's all if it is F, that means all are 1 1. So all the bits are 1, so that would be the broadcast. So the A is a unicast address because A is binary, is 1010, and the B1 is also it's a multicast because 7 is represented like this. So the last one, that is a C, is a broadcast since all digits are F. This is a similar example which you're sending the address. So byte should be start from left to right, and these bytes need to be converted to binary, and that binary should be sent from right to left. So 47 would be 01000111, and those bits should be from right to left. When it is right to left, this is the pattern that you observe. So 111, 000, 10, and so on for all of the other bytes. Next is the standard Ethernet. Um, these are the common implementations: the 10 base 5, 10 base 2, 10 base T, 10 base F. These are the different implementations. So we'll just look at it one by one. So 10 Mbps data, which uses a Manchester encoder and sent via twisted pairs or the fiber cables, and received with the, and then decoded with Manchester decoder, and receives the data. So this is about 10 base 5. So 10 means it is 10 Mbps. Base is nothing but the baseband, which is digital, and 5 means the maximum length of the cable should be 500 meter. Okay, so this, for in this category, it uses a thick coaxial cable, okay, which can have maximum of 500 meter, and this is a transceiver cable, which should be of maximum 50 meters in length. Okay, so this is one type. Next one is 10 base 2. So 10 again, 10 Mbps. Base means baseband of digital. Then 2 means here it means that the maximum the length of the cable would be 185 meter. So you can just look at this. This is a thin coaxial cable with the maximum of 185 meters, and all the systems are connected to it. The next category is 10 base T implementation, that is twisted pair Ethernet. Okay, so 10 base T uses a physical star topology. So you can look at this. This is acts like a hub, hence it is a star topology. So 10 means 10 Mbps base is baseband. T means it is a twisted pair cable. Okay, so you'll have two pair of UTP cables in each of this connections. Next is the 10 base F implementation. So 10 is 10 Mbps baseband, and F means it is a fiber optic cables that are used. So if you look at this, there are two fiber optic cables used for each node over here. Okay, and again it uses a hub, okay, which acts like a star topology. You can just see the different differences between the four different implementations of standard Ethernet. Just go through this. So next we'll see the changes in the standard. So the 10 Mbps standard Ethernet has gone through several changes before moving to the higher data rates. These changes actually opened the road to the evolution of the Ethernet to become compatible with the other high data rate LANs. So you can just look at the sharing bandwidth. Okay. Next, this is the network. See, this is with the bridge, and this is without bridge. So here it shows the collision domains in an unbridged network. So this is an unbridged network, and this is a bridged network. This is a switched Ethernet. You can see here separate slots for each of the domains. Okay, so the chances of collision is less over here. Next, we have full duplex switched Ethernet. As you know, full duplex means you transfer both ways at the same time. So you transit and receive, which all the nodes are connected to the switch. Next is the fast Ethernet. So fast Ethernet was designed to compete with LAN protocols such as FDDI or fiber channel. Okay. So the fast Ethernet is backward compatible with the standard Ethernet, but it can transmit data 10 times faster at a rate of 100 Mbps. Okay. So the standard Ethernet has 10 Mbps, where fast Ethernet has 100 Mbps of speed. That is the data rate. This is a fast Ethernet topology where you can see this is the point-to-point connection, and this is the star topology. So in the fast Ethernet, the implementations are of three types. So 100 base TX, 100 base FX, and 100 base T4. We'll see one after other. So if you look at this encoding for fast Ethernet implementation, this is how the implementation is there in 100 base TX. So you can see the 100 Mbps is split into 4 into 25 Mbps, and MLT3 encoder and a decoder is used. Okay. Also, there are two UTP category 5 cables are used. And if you look at 100 base FX, even here 100 Mbps is split into 4, and you are using NRZI encoder. Here you are using NRZI decoder. Okay, and here two fiber optic cables are used. Next you have is 100 base T4. So this is the implementation of a 100 base T4 where you're using 4 category, that is 3 UTP. So 4 wires of category 3 UTP is used. This is the summary of fast Ethernet implementation. You can just have a look at this. Okay. Next, we'll move on to the gigabit Ethernet. Even higher data rate was needed, so which resulted in the design of gigabit Ethernet protocol, which is 1000 Mbps, which is again 10 times more than that of fast Ethernet. And the IEEE standard for this is 802.3Z. So in the full duplex mode of gigabit Ethernet, there is no collision. Okay, and the maximum length of the cable is determined by the signal attenuation. Okay. So this is the topology of the gigabit Ethernet, where here you have point to point, and this is a star topology. Here you have two star topologies connected together. This is the hierarchy of star topologies. So there are 4 different implementations of gigabit Ethernet. So we have 1000 base SX, which means that 2-wire shortwave fiber cables are used. 1000 base LX, where 2-wire long wave fibers are used. So S stands for shortwave fiber, L stands for long wave fiber. 1000 base CX, so 2-wire copper cables are used. So C stands for copper. 1000 base T, which is a 4-wire UTP. So T stands for UTP cables. This you can see how 1000 base SX, LX and CX have been implemented, where NRZ line encoder and a decoder is used. Okay. Uh, Here it is 1000 base T where UTP cables are used. Here it uses 4DPAN5 encoder and decoder. So this is the summary of the gigabit Ethernet implementation. Just have a look at this. There are different characteristics like which media or the medium and the number of wires, maximum length, the block encoding and line encoding. This is the summary of 10 gigabit Ethernet implementation. So here again it has 10 gigabit base S. So S means again you use a short wave, and L is the long wave cable, and E means extended. So here you can see the length is extended. This is the maximum length is used for 300 meter, and this is for 10 kilometer. This is for 40 kilometers that can be used. I hope you understood whatever has been discussed in this video.
Thanks for watching this video. If you like, please click on the like button. Thank you so much. Thanks for watching.